Good morning, everyone. This is Alan. Today is a beautiful spring day, actually. I'm lighting up for the territories after I finish with you here this morning. Today is May 17th. We are now up to 11 students, so I welcome everybody. Again, please make sure that you follow up on our first assignment, which is to introduce yourself on the discussion board that I've placed, okay? Please make sure you keep up on everything that I put to my courses because we are moving at a good pace here. So this is going to be the second video regarding Chapter 2, and I left you yesterday, actually, and by now I have posted that video. I had walked you through how compounding of interest leads to a very substantial effect, which I illustrated through two tables. I left you with a formula here, which is pivotal to all of our studies of the time value of money, which relates to compounding and discounting. Now, as you see down here in this little Excel spreadsheet on lines 23 through 27, I've given you a timeline. I'm going to recommend you draw a timeline every time, at least throughout the duration of this course, as we get used to these concepts. I recommend you draw a timeline every time you do one of these problems to remind yourself, am I moving forward through time or backward through time? That's going to help you solve our problems, okay? So these all have to do with compounding of interest. Now, when we compound, as you can see here, on this timeline that I've put on line 25, PV stands for present value, FV stands for future value, of course. When you're moving from now until the future, or from a beginning point into the future, forward on a timeline, we call that compounding, as I illustrated for you in this graph, okay? It's a very powerful financial tool. When, however, you're moving backwards through time, we refer to it as discounting. And that's very important to us because we do want to know how to go forward into the future as money magnifies itself and gets bigger and bigger through the magic of compounding. But for purposes of financial analysis and understanding your investments and understanding day-to-day transactions that we make through the operation of money, interest, and time, you need to be able to move from the future backwards as well. Okay? So please draw a timeline. Let's get back to our PowerPoints. Pardon me while I finish my morning coffee here. Okay, you would not want to see me without my coffee. Okay, so I put a table up here to how compounding works. This is based on 5%, as I said yesterday. We invest $1,000 at 5%. That means in the first year we make 50 bucks. We add that to our running balance, and now we've got 1,050, and that is how much money works for us in year 2. So that is compounding. Calculating interest not only on your original $1,000 principal, but on interest as it accumulates as well. And that's where that amazing curve comes from that we see right there, okay? All right, so now, I illustrated with a table prematurely. I always like to do a table as a proof. I am not going to expect you to do a proof, but I find that doing one is helpful. So I'm going to throw a few of them in as we complete our lecture series on Chapter 2. I'm going to dwell on Chapter 2 a lot because it's very pivotal, as I've already told one or two of you by email. Okay? So, you could do it in a tabular fashion as you saw. You could do it by the magic formula I gave you, 1 plus I to the nth power. So if you invest $1,000 at 5%, by the way, in one of my verbal instructions yesterday, I think I might have confused 3 years and 5% or 3% in 5 years. I apologize for that, but I want to make that very clear today, okay? So we invest $1,000 at 5%, in this case for 7 years. That would be 1 plus 0.05, 5%, to the 7th power, 7 for 7 years. Okay? When you multiply that out, you're going to take 1.05 times itself 7 times. It's very tedious. Multiply that by 1,000. You get 407.10, just like we did in our table. No matter what happens, we're going to end up with 1,407, okay? Whether you do it in a table, whether you do it by algebra, or here comes what we will do here in this class, okay? Now, this is based on a single amount. That's very important to remember. Once and one time only. If you repeat an investment, we'll deal with that later through separate calcs. Right now, we're focusing on a one-shot deal, okay? All right, now this is our notation, ladies and gentlemen. Whenever we're doing time value of money calcs, you need to know an interest rate and an amount of time, okay? Once in a great while we solve for those. We'll deal with that later. That's later on, okay? To get up through page 30, which is our goal in this first module, we only need to know an interest rate and an amount of time. 5%, 7 years. We need to know the principal too, but those are the key determinants about which number on my tables you'll use. Okay, so now let's go and see how it works. Okay, as I told you yesterday, our time value of money factor tables, TVMF, takes two of those variables. Okay, what variables? Well, we see that interest is P times R times T. So the tables involve R times T, and the table looks like this. This is one of the ones right out of our book, friends. This is one of the ones you downloaded. Okay, my rates are across the top, my interest rates. Okay, down the side are the number of years. I call them periods for a different reason, but for now we'll call them years. Okay, so we know that if you have $1 today, it's going to be worth more in the future. So if you have a 4% rate and your dollar grows for 3 years, all right, the number at the intersection is 1.1249. That means your dollar will be worth roughly $1.13 3 years from now if it grows at 4%. So I've taken the R and the T and worked them into these tables. This is table number 1 or table A, okay? All right, so instead of using algebra, let's keep it a lot simpler. I don't like exponents, remember? And in the preceding calculation, we had 7 as an exponent. It's tedious and fraught with errors to multiply something by itself 7 times. The tables will take that issue away from us. So we're going to go to the first table. We're trying to say what is $1,000 going to be worth in 7 years if I make 5% every year. So I go to table number 1. Compounding, I am moving forward through time. That means I use table number 1. Okay, 7 years at 5% would be that number right there, 1.407. So $1 at 5%, 7 years from now, will be worth $1.40.1, something like that, or 41 cents, or 40.7 cents, however you want to express it. That is the factor. I've held it to 4 decimal places. Okay, these factors go out to a long decimal expansion. If you've ever seen the movie Office Space and the scheme that Peter Gibbons cooked up, it's based on this. That's a long decimal expansion. That means you could get rounding errors. I want to hold it to 4 decimal places for mathematical simplicity because this is an applied course, not a mathematics course. So now that's $1. I'm not dealing with $1 though, I'm dealing with $1,000. So I simply take that factor, 1.4071, and I multiply it by however much principal I'm using. I don't care if it's 1,000, 10,000, 100,000. I multiply it by that factor. Okay, so let's look at 1,000 times 1.4071. And there's that magical number again, 1.407. No matter whether you do it on the table, algebraically, or using my math tables here, my TVM tables, it's still going to work out to the same number. That's the beautiful part about mathematics, is it has to work every single way. Okay, I hope you found that helpful. Okay, all right. Using my appendix, the problem is that the interest rates, as you can see, are fixed. Look to the back of the book, 1%, 2%, 3%, 4%. Well, of course, we can use many different percentages, 3.5%, 3.8%. They're not here, are they? That's why I want you to download the tables, because you can change any one of these. I'm going to take that 3, and I'm going to say, let's say you used 3.5%. You just changed that to 3.5, and see how the numbers all changed? All right. I'm going to undo that because I don't want to pollute my tables. All right. I stopped at 50 years. What if you want to do 70 years? Okay. I can just change that to 70, and all my factors change. Okay. So that is why I advocate the use of my downloaded tables rather than the printed version in the back of the text. Those are handy, but they're not going to give you the flexibility that these downloaded Excel tables will. Okay? Please remember, 4 decimal places will suffice for our purposes here in our class. Okay, so what I've done is I've summarized everything into 4 formulas, one for each of our tables. Okay, so now rather than confuse you too much, because this is an accelerated class and I am throwing an awful lot at you, I'm going to digress a little bit and come back to this spreadsheet. Now you'll recognize this from yesterday's lecture, but I have expanded it quite a bit. First of all, I added the timeline. All right, always do. I've been in the finance business since, really since 1976, so I flatter myself when I say 40 years. But I still always draw a timeline just to be sure I'm keeping my math straight. And guys, when you do a math problem, here's an important secret of the day, safety tip of the day from Alan. Always do 2 things. Number 1, always check your math. Okay, every math professor will tell you that. But here's the second secret. When you're dealing with applied issues like finance, you ask yourself a second question. Does my answer make sense? Okay? If I'm asking you to determine how much $1 is worth in the future and you end up with less than $1, I think you did something wrong. Okay? All right. So now, here's what the tables do for you. Table 1 takes $1, and says, what will it be worth in the future? We just did that with that 1,407. Okay? Table number 2 takes $1 in the future and it moves backward on the timeline. It discounts for you. Okay? So you know you're going to end up with less because $1 in the future has to be worth less today because it's going to grow to $1. I don't care how many dollars you're dealing with. It reduces down to that simple a statement, friends. Okay? The other 2 tables, as I say on line 35, we'll deal with that later because they are shortcuts. Tables 3 and 4 are shortcuts. Okay? The real tables are 1 and 2. Now, I lined up a couple of problems here. Okay? Example 1 and example 2, I'm going to try to start those with you today. Okay? All right. Always say to yourself, self, which way am I moving on the timeline? If I'm moving forward, I'll use table 1. If I'm moving backward on the timeline, I'll use table 2. All right. These are the formulas, friends, that go with the tables. FV equals PV times FVIF. Oh, I hate algebra. Okay, but in plain English, the beautiful part about algebra is you can express it in English, ladies and gentlemen. Table 1. To find a future value, take the present value times table 1. Table 1 is the FVIF, future value interest factor. Table 2. Again, PV and FV stay the same, but table 2 gives you the PVIF, the present value interest factor. It is the reciprocal of table 1. Don't worry about it. You could say to yourself, well, I can solve a present value problem by dividing by the table 1 value. No. Financial people don't like that. Financial people keep their lives simple by saying, let's simply create a second table. Want to have a little fun in your free time? Well, you don't have any free time if you're taking an accelerated course now, do you? But you could take any value in table 2, all right, and you'll find that if you divide it, take 1 and divide it by that value, you'll get the table 1 value and vice versa, okay? So now, let's deal with this problem. Okay, that's example 2. Example 1, you have $5 today, you win a lottery or something, and you want to invest it at 4%, you can lock that rate in. How much will you have in 10 years? Oh, that couldn't be easier. So let's write that down here, example 1, okay? Hang on. Let me do this all in caps for you. So example 1, you're going to say 5,000, and it was 4%, I believe. Always write the facts down. What will it be worth in 10 years? All right, now, by the way, I have a few Excel problems because I use a Mac desktop, so please bear with me. There it is. Once in a while, it makes something vanish on me. Okay, now, you could take $5,000, multiply it by 1.04, 4%, and do that 10 times, multiply something by itself 10 times. No, we don't do that, okay? That's tedious. Plus, every time you do it, it's prone to error. You could make an error the more often you do something. No, what I'm going to do instead is I'm going to go over to table number 1. 4%, 10 years. There it is. Open up the table. 4%, 10 years. My number appears to be 1.4802. Okay? $4.802. All right, so how much money am I dealing with? $5,000. I'm going to multiply that by the factor I just found. Okay? And obviously, when you math that out, you're going to get 7,401. I'm going to put 2 decimal places on that. Okay? So that is how much my $5,000 should grow to. Now I'm going to do a proof for you. Again, I'm not going to expect you to do proofs in my class, in our tests, in our quizzes, in our homework. I recommend you try a few because it adds, it ratifies, it adds a ratification, an assertion that this does work. Okay, so I'm going to do one for you. All I'm going to do is find out the answer. You have just found the answer, friends, 7,401. So to do a proof, I'm going to put the year. I'm going to show how much interest we make every year. I'm going to show a running balance. Okay? How much am I starting with? I'm starting with $5,000, right? Okay. How long am I doing this? I'm doing this for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. All right. At the end of 10 years, if I did this right, ladies and gentlemen, I should see $7,401. Okay? And I'm going to put down pennies because I kind of like to see 2 decimal places when I do money calculations. You don't need to go beyond that. All right, how much interest do I make in year 1? I have invested at 4%, right? So I deposit $5,000. That money is going to make me 0.04. I multiply by 0.04, 4%. That means in the first year I make $2,000. How much do I have at the end of the first year? I have my original $5,000 plus I have the $200 I made, so I end year 1 with $5,200, not $5,000 anymore. Okay? So I'm going to do that again. In my second year, I have $5,200 times 0.04. Now I've got another $200 working for me. So I don't make $200, I make $208. I hope that the fact that I'm recording this is helpful because you can slow me down, replay me, fast forward if I get redundant, okay? So now at the end of year 2, I've got my $5,200 from the end of year 1 plus another $208. Now through the magic of Excel, I'm going to do the same thing 8 more times. Will you look at that? My goodness, at the end of year 10, I indeed do have $7,401. And I have a rounding error. I'll split it with you. Don't worry about that. Why? Because, again, I have truncated my, my tables. That 14802 is actually, you could expand that to 16 or 17 decimal places like in the movie Office Space. Right now we gain nothing by that. So I will accept a rounding difference. Okay? All right, very good. And it's going to be about time for me to end this video. So let me go back and make sure I haven't missed anything. I will close this table. Okay, when we reconvene, when I do another posting, which I may do tonight for you, I'm going to try example number 2, and this time I'm going to try running backwards. We're going to say, wait, I know what I want in the future, $25,000. I just have a newborn nephew, or my sister has a 1 or 2 year old baby, and being a wonderful honor uncle, I want that child to have $25,000 a year for a down payment for Dean College. And I know how much time I will accomplish that. I will take to accomplish that. And I know that I can lock in a 7% investment rate. So obviously I can start with a lot less money today. How much must it be? That's the question I will answer for you when we attack this again in my next lecture. Okay? So that is going to be all for now, and I hope you have a wonderful day. Have a good day. Bye-bye.